Hey there, Mustangs. Welcome back to another edition of No Here, No Problem. Um, Before we get started, I just got a quick question for you. Do any of you guys happen to know what's brown and sticky? A stick. Duh. Anyways, we're going to be starting a new new unit. And this unit, all the videos are going to kind of be a little bit lengthier in notes just because there's a lot of stuff that kind of goes into each one of the sections. In our first section today, we're going to be talking about in 2.1 quadratic functions. Now, quadratic functions, you guys actually know the gist of them. So if you want, feel free to fast forward, skip through a bunch of stuff. It's going to be the later ones are going to be a little bit longer, but I can tell you right now, this one's kind of going to probably be a little bit more lengthy, okay? So let's get started. So what you should learn in this is we're talking about quadratic functions, and we're talking about the standard form and then how to graph them, how to find the max and the min, and then some like real life applications that relate to quadratic functions, okay? So the graph of a quadratic function, this is a whole bunch of stuff going on. But when we look at a function and we say it's a non-negative integer, before we talk about quadratics, let's talk about polynomials, okay? And sorry, I should have started with that. What we're talking about is polynomials, and a polynomial is whenever we have more than one term. Poly means many, nomial means more than one. And so as long as we have more than one term, we are going to have, usually it's going to be something like a quadratic or a cubic or something else. But we'll talk about all those as we get to other larger functions, okay? Today we're just going to be focused on quadratics. So to start us off, when we have a polynomial function, there's ways of classifying them based off of the degree. So when we look at something like this first one here, where it says f of x is equal to a cannot equal 0. If it was 0, we wouldn't have anything. We would just have 0, and it would be a horizontal line at 0. But when we say that a is equal to a 5, so if we were to say like f of x is equal to 5, well, remember, f of x is synonymous with the y is equal to 5 means that we would have a horizontal line, right? But the degree of this, what's the degree of this function? Well, when we're looking for an x, I need to have a degree there. If I wrote an x, there would be a 1 right here by me writing it. The number that we use to imply that there's no x would be a 0. So that means that we have a degree of 0. And what we call this is a constant, meaning it's not going to change. There's actually no variable involved, so it just becomes a constant. Okay, so we've learned that a function that has a polynomial function that has a degree, in this instance when we look at it, I just talked about it, there's a 1 here. If it has a degree of 1, we call this a linear function. It's always going to end up being, a straight line, that if I put in one value for x, I'm going to get one value for y. So it's very linear. And again, what we're going to be focused on are quadratics. So when we look at a polynomial function that has a degree of 2, these are called quadratic functions. And the graph of a quadratic function is typically one of those special types of U-shaped curves that we call a parabola. Okay? Now all parabolas are symmetric. Symmetric means that they're going to be the same on one side as they are with the other. So they're going to be symmetric with respect to a line that is called the axis of symmetry. Now we're going to get into the equation of the axis of symmetry in a few minutes here, okay? But it's also called the axis of the parabola. It's the point where the axis hits the parabola. So you're going to have this line, right? And then we're going to have this U shape, and the point where it actually runs into the parabola, which is going to be right here. So when we draw this shape right here, there's a parabola and there's a line. That point where it hits it, or in this instance, when we go this direction, that point where it hits it, this point where it intersects is called the vertex. Okay, now it can actually end up being called a max or min depending on the picture. So in this case it's a minimum, and in this case it's a maximum, but it's called a vertex. So let's talk about the sketches of these graphs and what they look like. So if you remember, the graph of y is equal to x squared is simply going to be a parabola. Okay, when we talk about letter a, we talk about our transformations. This first part here, is negative f of x. So if you recall, what this means is that we're going to reflect over, because we're taking the opposite y value, we're going to reflect over x. And then the plus 1 is like saying f of x plus 1, which means it's going to go up 1. So what that means is that when we draw our graph for this, if I go ahead and put in my U-shaped curve here, I should have done that as one thing so I can grab all of it. Okay, that's my U-shaped curve. If I take that curve and I go ahead and rotate it, it's going to flip over and it's going to end up looking like this. That's reflecting over the x. And then we take that and we shift it up 1. This is what my new curve should look like. And let's confirm that. Okay, let's go here. Here's my original function, y is equal to x squared. If I reflect it and move it up 1, this is what the graph ends up looking like. Okay. For the second one, when we look at it, what we've got is f of x plus 2 that's in there. Remember that this is going to move it left 2, and then f of x minus 3 means down 3. Okay? And so what this means is that we're going to take our U-shaped curve that we have here, and we are going to take this curve that's right here, and we will go ahead and move it to the left 2, and then we will move it down 3. And let's take a look at that to confirm it. Left 2, down 3, there's my graph. Now what I want you to focus on is the lines that could pass, are the vertex in this, okay? My vertex, when we look at this graph, I'm going to use this screen here. My vertex, when I look at the graph, is right here. Now that point right there is at 0, 0. When I took my vertex, I moved it to the left 3 and then down, left 2 and then down 3. Now the vertex is right here at -2, -3. And if you could imagine right here, if I was to draw a vertical line in here, that vertical line that would pass right through it is an equation of x equals. Well, what does x equal here? X is equal to 0 in this equation. Let's write it in here so you can see the graph of that. X is equal to 0. And you can see this blue line pops up going right through the middle of my graph, creating an axis of symmetry, where you can see on both sides of my graph, on the right side of the graph here, it's all equal, and on the left side of the graph here, it's all the same. So it's balanced on both sides. And when we go ahead and look down at this graph right here, well, if I take my axis of symmetry and I shifted it over to the left 2, now my graph has an axis of symmetry at, -2. And you can see right there that the line goes directly through the middle of my graph again, and it's the same thing on the right as it is on the left. Okay? All right, let's go ahead and switch back here. So the standard form of a quadratic. Okay, now there's two different forms that you guys have probably seen. You got y minus k is equal to a times x minus h squared. Okay? This is a form that you might see the book using. This is a form that might be written somewhere. I personally don't like doing this because it goes against what we've always done, which is to have y by itself. So if you try to get y by itself, you simply move the k over, and it's y is equal to a times x minus h squared plus k. Okay? And when we look at this, h and k are my vertex. X and y are a coordinate. It's a point on my graph. Okay, so it's just an, oops, I'm blocking what I'm writing. It's an actual point that's on the graph when we're doing this, okay? So how do we identify the vertex of a quadratic function? Now there's two ways that we can actually do this. There's the first way, which is by completing the square. Okay, and then there's the second way, which is using two formulas, x equals -b over 2a. Now you'll notice that -b over 2a, this is something that's actually similar to the quadratic formula. Okay, this is actually part of the quadratic formula. And then the y value for this, to find the vertex, is going to be f of -b over 2a substituted in. Okay, geez, hang on, that got away from me, sorry. F of -b over 2a. So that's taking the Ugh, excuse me, got a sneeze there. It's taking the x value and plug it in to find what the y value will be. So let's do it both ways and see what we get here, okay? Completing the square, a little bit of a process. We start with f of x is equal to 2x squared plus 8x plus 7. And here's the process. You take the first two terms that are in your function here, and remember we talked about this before, taking this value that's right here and factoring it out of my function, okay? So if I factor it out, we're going to be left with a 2, and then x squared plus 4x plus 7. Okay? I took a 2 out from there, and we went ahead and said, let's take the 2 out. 2 divided by 2 leaves me with a 1, and 8 divided by 2 leaves me with a 4. That's where those values came from right there. Okay? So let's go ahead and complete the square. Half of 4, we're taking a look at this 4 here. Half of 4 is 2. Square that, we're going to get another 4. But now be careful. What I did in this problem was I didn't add in a 4. I actually added in a 2 times 4, which is equal to 8. So to balance it, if I added 8 to the right side, then I have to balance it by taking away from the right side an 8. If I add 8 in, see how I put 8 in? I'm going to take away 8, and it's like it never existed. So then to finish this, what we're going to have is y is equal to 2 times x plus 2 squared minus 1. Okay? And when we look at our vertex here, the vertex is at -2, -1. Again, always take the opposite of the quantity that we see there, that x plus 2. So let's look at the graph of this just to confirm it. So, whoops. Let's look at this. This is my original function, the 2x squared plus 8x plus 7. And this is the new function in its standard form. Now I can look at the graph and quickly just touch the vertex there and see that it's at -2, -1. We can tell that my graph opens in the upward direction because when we look at the leading coefficient right here, or the leading term, it's a positive, and positives will always open up, and a negative will cause that reflection and make it move down. Okay? How do I go about finding the vertex and the vertex from just taking the equation and pulling values? Well, my a value in this is 2, my b value is 8, so x equals -8 over 2 times 2, which means that x equals -8 over 4, which is -2. So we have my vertex at -2. Once I know that -2 is my x value from this function, we can plug it back into the function, and that will give me my y value. So -2 squared plus 8 times -2 plus 7. And we end up with 2 times 4 minus 16 plus 7. We have 8 minus 16 plus 7. We have -8 plus 7. So we end up with -1. And that's my vertex now. Okay? So 2 ways to do it. You pick and choose which way you want. I don't care either way. One is going to be easier than the other in certain instances. So, for example, when it says to find the minimum and maximum values, well, let me tell you something. First off, you see how this leading term is negative? That tells us, without even graphing it, that the graph is going to actually look like this. So that tells me that I'm not finding a minimum here. I'm going to actually be finding a point at the top, which will be the maximum. Now watch what happens if I do this the hard way. If I do this completely in the square. We have f of x is equal to -3x squared plus 8x plus 4. I'm going to do what it said. I'm going to group the first 2 terms together, and we're going to take that -3 out. So we'll have -3x squared plus, minus 8 over 3 x, and then plus 4. And again, all I did was I just took this and divided it by -3, and I took the 8 and divided it by -3. And that's how I got those 2 terms that we see there. Okay, let's complete the square. Half of 8 is just 8 over 2. I'm sorry, no, back up. Half of 8 over 3 is 8 over 3 times 1 over 2. So that's just 8 over 6, right? Well, 8 over 6 is going to reduce to 4 over 3. And if I take this and I square it, I'm really going to be adding in a 16 over 9. Now to keep this balanced, I put in a -3 times that, which means I'm really putting in a -16 over 3. Okay, that's what I'm adding in, is a -16 over 3. And so to balance this, I'm not going to put in another -16 over 3. I'm going to put in the opposite, which is to add in a positive 16 over 3. So now let's write this in its binomial squared form. We're going to have -3, and then we're going to have x minus 4 over 3, right? Let me confirm something here. 8 over 3 times 1 over 2 is 8 over 6, and that's going to be 4 over 3. Yeah, Just making sure. Sorry, just didn't feel right. It's late, I'm tired, and my brain is not fully functioning right now, let me tell you. And then the last part here is let's combine that 4 plus the 16 over 3. So I'm going to actually make that 4 a 12 over 3. So that 12 divided by 3 is 4. That'll join up with the 16, and we're going to have 28 over 3. So that means my vertex for this should be 4 over 3 and then negative 28 over 3. Okay? So now let's try doing it mathematically with the negative b over 2a. X equals negative b over 2a. That means we're going to have x is equal to negative 8 over 2 times negative 3, which means x equals negative 8 over negative 6, which is going to equal positive 4 over 3. That matches what we said on the other part there. Okay? We'll put that back into my problem. We have negative 3, 4 over 3 squared, plus 8 times 4 over 3, plus 4. And that means we have negative 3, 16 over 9, plus 32 over 3, plus 4. We're going to have negative 48 over 9, plus, geez Louise, some big numbers here. I'm going to multiply this denominator by 3 just so I can get a 9 in the denominator. And that means we're going to have 96 over 9. And then I'm going to multiply, let's see, I need this to be a 9, so I'm going to multiply this by 9, and that's going to be 36 over 9. Okay? And if we put these together, I'm probably wrong. I probably made a mistake here. 96 plus 36, 132 minus 48, 84, and 84 divided by 3 is 28. Yeah, so this actually works out. So we have negative, no, we have positive. I messed up somewhere. Ugh. Let's see where we went wrong here. So we put in 4/3. Oh, there's a mistake. I said when I looked at this, it's a negative 28 over 3. It's actually a positive 28 over 3. So I caught my mistake. Sorry. And so when we simplify this, this will end up being times 3. This will end up being 84 over 9, which is going to reduce and equal 28 over 3. So we end up with 4 over 3 and then 28 over 3. There you go. Whew, we made it. A lot to do without a calculator. All right, let's continue on here. So the maximum height of a projectile. So in this case, what we're talking about is the path of a baseball, and we should be able to see some pretty obvious things. The leading coefficient here is a negative. So that tells us that what's going to happen is we're going to have a picture that's going to look something like this. It's going to go up and it's going to go down. Now, I want you to notice something. I started this picture up above 0. The reason I started above 0 is because of this right here. That value right there is known as your y-intercept. So that happens when x is equal to 0 in my problem. I mean, if I put a 0 right here in for this x, I get 0 times, or 0 squared times that whole thing, which means this all goes away. And if I add a 0 to it, it means that that goes away. So it's just going to be a 3. And that should make sense because it's a ball getting thrown. So if I throw a baseball and somebody's trying to hit it, it's not usually on the ground. It's usually maybe about 3 feet off of the ground. Okay? And so let's take a look at this when we go ahead and use our values for x equals negative b over 2a. So x equals negative 1 over 2 times the quantity, negative 0.0032. And we're going to get that x is equal to, and I jumped ahead and did it. It's actually going to end up equaling 156.25. So that's the x distance. Remember, x is always going this direction. That's the horizontal distance as we move across. So then the question becomes, well, how high can it go? If we take this 156.25 and we plug it back into my function here and solve, we'll get an answer of 81.125 feet. So that means the highest this will go is 81.125 feet, and the farthest it will go to get to that point, not all the way across, it would be 156.25. And then if we went ahead and continued another 156.25, you would see that we would be at 312.5 for the total. So let's see if this matches up with our picture here. Okay, I've got this picture right here. Now that looks like a really wonky straight line, but you should notice there that it actually starts right there, and it starts at 3 like we talked about. Let's zoom out and see what this picture looks like though. There's the curve now. And you can see at the very end of it, right above me here, that's going to be at about, like I said, 300 and change. And the vertex right here at the top of this, whoops, is going to be right there at 156.25 and 81.125. All right, let's move on to some more fun stuff. We've only got a couple slides left here. This one, we're writing the standard form of a quadratic function with a vertex of y at -3 and a point -1, 2. Now, I already talked to you guys about that. That's this right here. That's just taking this equation that we see right here, plug it in a vertex, plug it in a point, and the only thing that's missing is the a value. And remember that the a value is important. It tells you if there's like a stretch or a shrink that takes place, okay? And again, that's going to be in the vertical direction when we're talking about that. So when I say stretch or shrink, what I should have done was instead of going side to side, I should have been saying up or down for the vertical direction. A stretch or a shrink in the vertical direction. Let's see what we mean. So if I start with my function y is equal to a times x minus h squared plus k, and we look at the values that are given to me. So this is my h, this is my k. We have y is equal to a times x plus 3 squared, and then minus 3. Now we're given two other values in this problem. We're given an x and a y. Those values will go in for my x and y, and we're going to have a 2, an a -1 plus 3 squared minus 3. I'm going to go ahead and start simplifying this so we could solve for a, and we're going to end up with a 2 squared minus 3. So that means we're going to have 2 is equal to 4a minus 3. The common mistake that people do at this point is they actually take these two and put them together right away. And you have to realize that you can't do that. You have to fight the surge. That 2 squared is actually attached to this a right here. That's why I put the 4 in the front, just so we can really see that the 4 is up front with the a. Don't try to combine it with that 3. Add 3, we end up with a 5. And then if I go ahead and do this in one step, I divide by 4, we end up with a is equal to 5 over 4. So if we put this back together without the given point, we can use my vertex here. We're going to have y is equal to 5 over 4. And then we're going to have x plus 3 squared, and then minus 3. Now I can check my answer for this. Vertex is at -3 and -3, and the coordinate is at -1, 2. I put that there. I'm going to label it. I'm going to go back to my home so I can see it better. And then let's go ahead and I accidentally moved this point down, so I'm going to move it back up so it's with it. And you can see there's that point. Now look at this curve right here. You can kind of see the shape of this already, that it's going to kind of have two possibilities that could really happen here, right? We can have that it goes up and around, or we can have it go down and then around, right? But the issue is that I don't have control over which way it goes. The values dictated it for me. So here's the function that we came up with. There you go. We can see this actually works. It gives me my exact picture here. Okay, 5 over 4, x plus 3 squared minus 3. Okay, and it goes through both of those points. All right, let's move on. These are a doozy. You ready? So for this one, it says find two positive real numbers whose product is a maximum. So the function f of x is going to equal x times y. Here's what I'm doing. I'm saying that x equals the first number and y equals the second number. Okay, so let's go ahead and set this up. We have that the product is going to take place, and what's going to happen is from this picture we're going to have a max. Now let's work on the second equation. It says the sum of 3 times the first. So my first number is x. 3 times this would be 3x. And half of the second, well, my second one is y. Half of this is y over 2. And this is going to equal 60. Okay? Now, what you could tell right away is that what we've just done is we actually set up a system where we've got two separate equations going on. So we got to solve for one and plug it into the other one. So let's do this. Let's actually take and make this all in terms of x. Okay? So that means if I multiply this one by 2, we're going to have 6x plus y is equal to 120. That means that y is going to equal 120 minus 6x. Now, what does that do for me? I now know that y is equal to 120 minus 6x. I could take that and put it over here for this y. And when I do that, now here's what the equation says. It's going to be x times 120 minus 6x, which means that we're going to have negative 6x squared plus 120x. And there we go. Now we've got a quadratic. So let's go ahead and find what is my vertex for this, because that's what's going to maximize this. We can see it's a negative, so that tells me that it's going to have that U shape, but it's upside down, so the top point will be a max. And we have to find out what is that coordinate, because that point is going to be the max, and those two, the x and the y, together will give me my answer for this. So if we go negative b over 2a, that means we're going to have negative 120 over 2 times negative 6, which will mean we'll have negative 120 over negative 12, which means that we get 10. So my x value for this is 10, and then my y value is going to equal 120 minus 6 times 10, which means we're going to end up with a 60. So the numbers are 10 and 60. Okay? So the sum of 3 times the number, 3 times the number in half the second, 10 and 60 meets both of the needs here. And the maximum value that I can get from this is going to be 600. Okay? Because 10 times 60. Let's do this again. Let's try this for the positive real numbers whose product is a minimum. All right, the difference of the first, so we're doing the product again. And this time it's going to be a minimum. So that tells me it's going to be a U shape, and the bottom of this is going to be the curve. The minimum. And let's go through the difference of the first and twice the second. So there's the first, it's x, and twice the second is y, is going to equal 18. Let's go ahead and do the same thing we just did, 2y plus 18. We'll take this and substitute it back into this y right here. And then we're going to have equals x equals 2... Nope on a rope. I'm going to actually change what I just said. I don't know why I just did that. I don't want to solve for x. I know that was the easy thing to do. I actually would have solved for y. Sorry. All right, so here's what I'm going to do. We're going to back up. We're going to move this over so it's negative 2y is equal to negative x plus 18. We end up with y is equal to 1/2 x minus 9. And we substitute this in. We're going to have 1/2 x minus 9, which means we're going to have 1/2 x squared minus 9x. Okay, I did this because when we do the quadratic function stuff, the negative b over 2a, it says x equals. Not y equals, it says x equals. So I needed all of my values over here to be in terms of x. That's why I needed to make that change. Okay. All right, so x equals negative b. That's going to be a positive 9. Divided by 2 times a, which is 1/2. So that means we're going to get 9 over 1, which equals 9. Okay. The y value for this is 1/2 of 9 minus 9, which means I end up with 9 over 2 minus 9, which is the same as saying 9 over 2 minus 18 over 2. So we end up with a negative 9 over 2. So it says 2 positive real numbers whose product is a minimum. The difference of the first and twice the second. And so when we go ahead and look at this, the values are going to be 9 and then negative 9 over 2. Okay. All right, let's go ahead and move on to the last ones. So these are, let's find the vertices of the given functions, identify if they open up or down. What I would recommend is pause the video. You guys try to do these on your own and then come back and take a look, okay? I'm not going to actually do all the steps. I'm just going to show you in the graphs here, okay? So when we look at this one right here, because it's a negative, it's going to be this upside down shape. So this will open down, okay? This is a positive, so it's going to look like this. So it's going to open up. This is a negative, so it's going to open down. This is a positive, so it's going to do this, and it's going to open up. Okay, now your vertex, let's look at each one of these. Ready? I'm going to turn each one of these off. All right, the first one, negative 4x squared plus 16x minus 11. Vertex for this is at 2, 5. So that one's 2, 5. The next one is going to be 6x squared minus 3x plus 7. Oops, I don't want that point. So it's going to be 0.25. Oops, and then 6.625. what do we say? 625. Okay. The next one here is going to be at 4.8. And then the last one here is going to be a minimum, and that's going to be at, whew, okay, hang on. I got to zoom out for that one. Sorry, I was blocking your way there. That's a doozy of one right there. That's going to be 0.5625 and then negative 21.094. Okay, I'm going to actually just leave it there to end the notes. Okay, so as you can see, this isn't really anything too new. More of the same. It's just practice with quadratics. But what's going to happen is you need to get extremely proficient at quadratics, because what's going to happen is through the rest of this unit, we're going to add on an x cubed, an x to the fourth, x to the fifth, x to the sixth, and you're going to be finding all these different, you're going to have all these different functions that you're going to have to chip away at until we get back to a quadratic. And that's where we're going to start being able to use the tools that we need to find and solve every part of our quadratic, okay? So feel free to come back to this anytime. Let me know if you have any questions. Otherwise, please like and subscribe so you know when you get my updates, and take care of each other, be good, and be safe.